Good day to everyone. I am Farana Tultul, and these are my group mates, Lian Duan, Lovish Dureja, and Rahul Amrishbhai Patel. The name of our web search engine is CoolGo. It believes it's cooler than Google. Next slide, please. So, what is a web search engine and how does it work? A web search engine is essentially a very large data mining application where various data mining techniques are used, such as crawling, indexing, and search. In other words, it is a software application that crawls the web to index web pages and provides information based on the user search query. In this, some search engines go beyond that and also extract information from various open databases. Usually, the search engine provides real-time results based upon the backend crawling and data analysis algorithm they use. The results of a search engine are usually represented in the form of URLs and with an abstract. Next slide, please. Okay. During the early development of the web, there was a list of web servers edited and hosted on the CERN web server. As more web servers went online, the central list could not keep up. As a result, the very first tool used for searching on the internet, Archie, was created in 1990 by a bunch of computer science students at McGill University in Montreal. Over the years, many other web search tools were created by upgrading Archie. In the summer of 93, no search engine existed yet for the web, though numerous specialized catalogs were maintained by hand. Oscar at the University of Geneva wrote a series of Perl scripts that would periodically mirror these pages and rewrite them into a standard format, which formed the basis for W3 Catalog, the web's first primitive search engine that was released in September 1993. Over the years, through various changes and upgrades, finally, we have the search engines we use today. We have quite a few famous web search engines, such as Google, that was created in 1998, Yahoo in 2004, and Bing in 2009. That's all from me. The next part will be explained by Lavish. Thank you.
Thank you, Prana, for explaining all this introduction. Now I would like to explain about the problem statement. Like the main statement is that how to implement a web search engine by applying the concepts that we have already learned in our class now, like the main methods, that the sorting methods, the searching techniques, the hashing methods that we have included. We will combine all these things in a single web search engine, and we optimize a better solution for the web search engine, because mainly because with the web search engine we just go through internet search engine and get the relevant web pages, the scrolling, the sorting, the best sorting methods, which will help us to conclude the best results of our outcome of the web search engine. Now my another colleague Lian Duan will explain about all the implementation and the methodology that we have used for making this web search engine. Over to Lian.
All right, thank you, Lovish. As to the methodology, on the left-hand side, block diagram displays all main components in high level about the search engine. We can see that the text preprocessing and the page ranking are the biggest parts of this diagram, and they contain most features that we have implemented for our project. On the right-hand side, the flowchart gives us more detailed information about the search engine, including the sequences and the logical operations. So in this diagram, we can see there are three condition blocks, and these three blocks will change the direction of this diagram by user's input. Based on these two diagrams, we summarize 6 main features that we achieved in our search engine. Firstly, in the crawler, we used GSIF to translate HTML to text to get the web page content. Secondly, by using regular expression, To find the patterns, we are able to remove unnecessary characters for text and preprocessing. Thirdly, the spell checking function will be called when there are some wrong spellings in the input. Then, the inverted index input by the txt is used to map the word occurrences and the web page to make a preparation for the page ranking. The last two features are the final bits of the search engine. Based on the sorting of the frequency, users will be able to see the most related ranking results on the screen. In the, in the implementation part, we create a demo to illustrate how the search engine works. So when we click to start the driver.java, and we can type in the words or the phrases that you want to search. So in this case, we have a typo for the nothing, and it will automatically correct it. At the bottom of the output, you can choose if you want to see more readouts. So we say yes, and then we can see the next page. If we choose no, and we will have a chance to retype the new words and the phrases. So this time we type COVID-19 cases, and then we type in 15 records, and display the 15 records by the ranking. And we choose not to display more, and then we choose to type 2 to exit the program. The next part will be explained by Lovish.
Thank you, Lian, for explaining about this, the methodology and the implementation, that how we're going to work. And I would like to explain about the conclusion of this part, like what we have to include in this. The next slide, please. Yes, we have mainly done this the four parts, like the web crawling, which is mainly used to convert the HTML into a text processing, like it will remove the stop words, streaming and the spell checking word, inverted index, and the page ranking, which will like we will mainly used for the search try and for the sorting methods, like which page will come first and which will be at the last. We have done all this part in this, and this is all about the implementation. And the next thing will be the future goals and the future concepts that we're going to take, and it will be explained by the Rahul. Yes, Rahul, to you.
Thank you, Lovish, to conclude our work. Now I'm going to explain future goal of this project. Our web search engine is not complex like Google, and there are many features we meant to add in this search engine. First of all, we will focus to improve efficiency of the search because for us, search quality is more important. Moreover, we use 500 HTML files to create a dataset, but in the future, we would like to increase the scale of the dataset. Next, we would like to make our search engine more accurate, so it will be satisfy the requirement of user searches. In addition to these, there are a lot of factors we would like to improve, like security and accessibility, page speed, optimized content, good graphical user interface, and so on. So our immediate goal is to make a GUI for the web search engine. In the next slide, uh, there are references we use to make a web search engine. It is very helpful to know about history of web search engines and the constant improvements in those search engines. Moving forward to our contribution, we created project on a GitHub. We work together by using Microsoft Teams. For individual contribution, Farana implemented two features. First, she used regular expression for finding patterns in dataset. Another, she implemented a feature of removing stop words like articles and symbols. Lian worked on inverted index. In addition to this, he used sorting and hash tables for ranking web pages and analyzing frequent results respectively. Lovish implemented two important features like word stemming and translate HTML to text using JSON. I implemented spell checker using try and edit distance algorithm. It checks spelling and suggests correct word from the dictionary. So thank you for your participation. This is the end of the presentation. If you have any question, please ask.